Hopefully this page will be a review for you. We're talking about the end behavior of polynomial functions. Remember, if your polynomial has an even degree, it's parabolic in shape, but it can do crazy stuff in the middle. So if the leading coefficient is positive, it opens up, and if it's negative, it opens down. So this is your end behavior. As x gets bigger, y gets bigger. That's what that means. As x goes to infinity, y goes to infinity. As x gets smaller, y gets bigger. So as x goes to negative infinity, y goes to positive infinity. That's what all of these in this box are telling us. Look at this one. If it opens down, as x gets smaller, y gets smaller. I jump down to this one. If x gets smaller, y gets smaller. And then as x gets bigger, so if x is going this way, y is going this way. So as x gets bigger, y gets smaller. Okay, so that's your end behavior for even degreed polynomials. Odd degree polynomials, if you remember, they make this S shape, kind of like the cubic function. So if the leading coefficient is positive, it goes this direction, and if it's negative, it goes this direction. Okay, so looking at the positive coefficient, if x is getting bigger, y is going up, so y is getting bigger. If x is getting smaller, y is getting smaller, so y is going to negative infinity. So as x goes to negative infinity, y goes to negative infinity. And if the leading coefficient is negative, as x gets smaller, y gets bigger. So that's what this one means. As x gets smaller, y gets bigger. And as x gets bigger, y gets smaller. As x gets bigger, y gets smaller. That's what all this means in this box up here. So hopefully you can remember those from the previous sections. A turning point is a point on the graph where the graph changes from increasing to decreasing or from decreasing to increasing. And a polynomial of degree n will have at most n minus 1 turning points. Looking at these two examples, find the maximum number of turning points of each polynomial function. Well, what is the degree of this function? The degree of this function is degree 5. Whenever you're looking at your degree, it will tell you two things. If you remember from the last section, it'll tell you at most how many zeros to look for, and from what we just said, it will tell you at most how many turning points to look for. I don't think I can squeeze all that on here. There we go. So if we have at most n minus 1, we have at most 5 minus 1 or 4 turning points. Now remember, this is at most, so it's 4 or less turning points. How about this one? If you were to multiply all this out, what would the degree of this polynomial be? Well, this one would give you x squared and some stuff. This one already has an x squared. Then you have to multiply this x squared times this x squared, which would end up giving you an x to the 4th term, right? It does have a negative leading coefficient, but right now we don't have to worry so much about that. This is an x to the 4th, so a 4th degree polynomial, which means it will have at most 4 minus 1 or 3 turning points. So let's put all of this together into one problem. Oh, there's a global maximum, global minimum. I forgot about that. So a global max and a global min would be the absolute highest point or the absolute lowest point on the function. Now, if your function continues to go up, there is no absolute or global max. And if it continues to go down, there is no absolute or global min. Okay? So let's look at this problem. we have this function. We want to find all the zeros and their multiplicities. Remember, the zeros are when you find your x-intercepts. It's in this part right here. So that's where you let y equal 0. So -2 equals 0, x plus 3 equals 0, x minus 5 equals 0. That one doesn't make any sense. Subtract 3, x equals -3, add 5, so x equals 5. These are going to be our zeros, but we need their multiplicities. The multiplicity of -3, the exponent where it came from, is 2, so it has multiplicity 2. This 5 came from this factor, that exponent is 1, so it has multiplicity 1. So find the zeros and their multiplicities would be this right here. Find the x-intercepts and list each as a cross point or a touch point. Well, the x-intercepts are the zeros in ordered pair form. -3, 0, and 5, 0. Sorry about that. There we go. And the multiplicity is what tells if it's a cross or a touch point. Multiplicity 2 is even. That's a touch point. Multiplicity 1 is odd. That's a cross point. Determine the end behavior of the graph and the maximum number of turning points. Alright, so looking at this function, the leading coefficient is -2. If you multiplied it out, that would be -2x squared times another x. So it would be a -2x cubed something something something, right? If you just look at the first little bit in each one and the exponents that go with them, it tells you what the degree is. Okay, so since we know that it's degree 3, it is degree 3. That means it makes this shape. But since the leading coefficient is negative, it actually goes this direction. Correct? That means as x goes smaller, y goes bigger. As x goes to -infinity, I forgot you can't see that. As x goes to -infinity, y goes to what? And as x goes to infinity, y goes to what? That's what we're trying to figure out. So I'll bring the picture down here. Our picture looks like this. If x is going this way, isn't y going this way? So y is going to infinity. And as x is going this way, y is going this way, which is -infinity. So this is your end behavior. And they want to know the maximum number of turning points. That's going to be n minus 1. Well, 3 minus 1 is 2. Alright, so let's draw on the graph what we have right now. We have the point -3, 0. We have the point 5, 0. And we know that it is going up on this side, and we know it is going down on this side. That's all we know at the moment. We're going to come back and get this local maxima and minima and the absolute maxima and minima. The absolute will be the same as the global. These mean the same thing. And then we're going to finish sketching the graph. What I want to do now is go to your calculator, because we really haven't talked a whole lot about this part. So go to your calculator, y equals, type in your function, and I did change my window, but let's just see what's going on. Okay, that didn't help me a whole lot. So I'm going to do zoom 6 and see what it looks like at that point. So we know it's coming down from this direction, touching and going back up. Didn't we say that right here at -3 it's a touch point? So it's coming here, it's going up. We don't really know how far it's going up, but it's going all the way up somewhere and coming back down, and it's going through this point. Correct? So that means there's going to be a local min at this point. So if we're looking at D, we have a local min at, let's see, it is 0 and it occurs at y equals -3. Sorry, I said that wrong. At x equals -3. So y equals 0 at x equals -3. And we don't have any other local mins, but we do have a local max up here somewhere. We have to figure out what that point is. So we're going to do that with our calculator. Go to, we need to see more y's because we can't see the top of this bit right here. So let's go to the window. I'll just put 50 and see what happens. Ooh, it's still off the screen. What I want to see is what's going on up there. So go back to my window, change this to maybe 100. We're getting closer. I still need to see what's going on right there. So change this to 200. As soon as you can see your whole graph, you're good. So this is somewhere around the 200, between 100 and 200 right there. So this is way off of my grid, in other words. So what I want to do is do second calc, and I want to find a maximum. So I'm going to hit number 4. The calculator is saying, are we on the left side of that maximum? The maximum is there. There's my cursor. So I am on the left side of it. Enter. Am I on the right side? Well, let me get over there. Now I'm on the right. Guess yes. So it's going to tell me approximately what my maximum is. Here is my maximum value. It's going to be 151.7, and it occurs at x is approximately 2.33. Okay, so that's my local max and my local min. E and F, sorry. E and F are pretty much the same. If you have an absolute and if you have a global, they mean the same thing. So looking at this graph continues to go up this direction, continues to go down this direction. That means there's not an overall maximum or minimum. So we can just say none. And we've already sketched the graph. This is good enough for our purposes. So we're done with this problem.